You are given the second derivative, one single point, and asked to find the entire equation of a curve. Most students panic when they see d squared y over dx squared, but this is actually a secret roadmap. Today, I'm going to show you how to use integration and the stationary point hint to solve this problem. Let's dive in. We start with the second derivative, d squared y over dx squared equals 6x minus 18. To get back to the original function y, we have to integrate twice. Let's start with the first integration to find the gradient function, dy over dx. So, we are going to use the power rule to integrate the function 6x minus 18. For the first term, 6x, it will become 3x squared after using the power rule. As for the second term, negative 18, it will become negative 18x. So, the integral of 6x minus 18 would be equal to 3x squared minus 18x plus c. Now, here is the trick. The problem says there is a stationary point at 2, 3. At any stationary points, the gradient is 0. So, we substitute in x equals 2 and set dy over dx to 0. We get 0 equals 3 times 2 squared minus 18 times 2 plus c. So c equals 24. Our gradient function is dy over dx equals 3x squared minus 18x plus 24. Now we are ready for the second integration to find the original function y. Let's integrate the gradient function, 3x squared minus 18x plus 24 dx. The term 3x squared will become x cubed. The second term, negative 18x, will become negative 9x squared. And for the last term, 24, it will become 24x. So, the integral of 3x squared minus 18x plus 24 dx equals x cubed minus 9x squared plus 24x plus c. To find this final c, we use the coordinates 2, 3. When x equals 2, y equals 3. So, 3 equals 2 cubed minus 9 times 2 squared plus 24 times 2 plus c. Solving for c, we get negative 17. So, the equation is y equals x cubed minus 9, x squared plus 24, x minus 17. Now, let's start with part B and C, where we are going to identify our local minimum and maximum. So, how do we find the local minimum and maximum? We usually look at where the gradient is 0. We already know that the first derivative is what identifies the gradient, and we usually set it to 0 and solve for x. So, dy over dx equals 3, x squared minus 18, x plus 24 equals 0. As you can see, we can factor out 3, so we will get 3 times the quantity x squared minus 6x plus 8 equals 0. Now we can factor our function, therefore 3 times the quantity x minus 2 times the quantity x minus 4 equals 0. Let's find the stationary points, in which it is a point on the graph where the function stops increasing or decreasing and becomes flat. We can get our stationary points from the function we factored earlier. So we have x equals 2 and x equals 4. But which is which? We use the second derivative test, which is our original equation given in the question. D squared I over dx squared equals 6x minus 18. Let's test x equals 2 in the second derivative. So 6 times 2 minus 18 equals negative 6. Since the answer is negative, this is a local maximum. Now let's test x equals 4. So 6 times 4 minus 18 equals 6. Since the answer is positive, this is a local minimum. And there you have it. We moved from a second derivative back to a cubic function. If this step-by-step breakdown helped you, hit that subscribe button and give this video a thumbs up. Drop a comment below if you want me to solve a specific problem next time.